In this video, we are going to learn about the center of mass. So there's a special point in a system or object called the center of mass that moves as if all of the mass of the system is concentrated at that point. Essentially, it's where if you held the object at that point, the object can balance perfectly. So you can try it with your pen or your pencil or a meter stick, anything like that. So this is related to momentum because momentum is only conserved if there's no external forces acting on the system. So when there are no external forces on an object or a system, the center of mass does not change. So what that means is, let's say something explodes apart. Let's say a water balloon. There's no external forces in that case. There's just internal forces. So technically the position where the center of mass is in that water balloon should not change. So let's look at this more mathematically. So the equation for the center of mass looks like this. They usually write it as a summation, but I think it's easier to look at it like this. So this is just saying, if you're looking for the center of mass along the x-axis, it's the first mass times its coordinate plus the second mass times its coordinate plus the third mass times its coordinate over the sum of all of the masses. So if you look at this diagram, the center of mass is closer to where the heavier mass is, which just makes that makes sense. If you imagine going on a seesaw, the heavier person has to sit closer to where the seesaw is balanced. So let's take a closer look at the center of mass. So this mass, M1, is bigger than this mass, M2. And the center of mass is closer to this one. If we were to make object 2 bigger, then the center of mass should move closer to M2. And sure enough, the bigger M2 is, the more the center of mass moves towards it. Now, let's make them the same amount of mass. So both their masses are 5.5, so the center of mass is directly in the middle. And if I separate them apart from each other, the center of mass stays in the same spot. And that would be because this is kind of like an explosion here. There's only internal forces acting on those objects, or at least you can imagine it to be that way. Let's put these a little closer together. And if we make object 1, if we make that mass bigger, then the center of mass is going to move towards that one. All right, so let's go back and look at some more problems here. So the first problem involves a seesaw. So a 59-kilogram woman and a 71-kilogram man sit on a seesaw that is 3.5 meters long. Where is their center of mass? So with these problems, it's really important to visualize it. So I visualized it like this. So I put the woman on the left and the man on the right, and it's 3.5 meters across. When you're solving these problems, you want to make one point of the problem, you want to call that 0. So I think it's always easier to choose one of the objects in the problem and make whatever their position is 0.0. So I'm going to say that the woman is at a position of 0, which would mean that the man is at a position of 3.5. So we just want to use this formula now. We only have 2 objects, so it's just going to be object 1, the woman, times her coordinate, plus the mass of the man, times, he's object 2, times his coordinate over the sum of their masses. So since the woman is at a position of 0, we just plug in 0 there, and the man is at a position of 3.5. So the center of mass is 1.91 meters away from the woman. So let's think about if this makes sense. So the center here is right about at 1.75. Since the man has more mass, it makes sense that if we wanted this to balance, we would have to move this fulcrum a little bit closer to the man. So we could have put the man over here or made this 0 and this negative 3.5. You would just have to sort of say this final answer differently. We could have also made the middle. We could have made that point 0. But again, if you make one of the objects, if you call that the origin or position 0, that makes some of the math a little bit easier. All right, I've got 2 more sample problems. So we want to calculate the center of mass of this system here. So we've got a mass of 10 kilograms at 1, 0, a mass of 2 kilograms at 2, 1, and a mass of 5 kilograms at 0.01. So we need to find actually kind of 2 center of masses here. We want to find the center of mass along the x-axis, and we want to find the center of mass along the y-axis. So we can find them separately. So there's 3 objects here. So and I'm going to say that this is object 1. I'm going to say that 10 kilogram mass is object 2, and the 2 kilogram mass is object 3. So it's each of the masses times their coordinates added together over all of their masses added together. So the 5 is at an x value of 0, the 10 is at an x value of 1, and the 2 is at an x value of 2. So that's why I have this up here on the top, and 5 plus 10 plus 2 is 17. So you end up dividing those 2, and you get 0.82 as your center of mass along the x-axis. So that's going to be right around here-ish. Remember, this is object 2. Now we want to find the center of mass along the y-axis. So we're going to just substitute in our y coordinates. So our 5 kilogram mass is at a y value of 1. Our 10 kilogram mass is at a y value of 0. And our 2 kilogram mass is at a y value of 1. So the center of mass in the y direction ends up being at 0.41. And let me show this a little bit more clearly. So the exact center of mass in the x direction is 0.82, which will be around here, and 0.41 in the y direction. So the center of mass is going to be right around here, which makes sense because it makes sense that the center of mass is going to be a bit closer to the heavier masses. So yeah, I just feel like that makes physical sense there. And notice that the center of mass is not even close to the center. It just really depends on the values of the masses. Okay, this last problem. An old go-kart with a mass of 300 kilograms is traveling in a straight line at 80 meters per second. It is followed by a four-wheeler with a mass of 200 kilograms moving at 60 meters per second. How fast is the center of mass moving? So in this problem, instead of finding a coordinate for the center of mass, we actually want to find the velocity of the center of mass. So we've got this 300 gram or kilogram truck traveling at 80. And then this four-wheeler, which has less mass, traveling at 60. So their center of mass, we just want to know how fast is it traveling. So we just want to use the formula that we've been using, except we can make the x or the y a v for velocity. So it's going to be the first mass, the first mass times its velocity plus the second mass times its velocity divided by the two masses added together. So it'll be 300 times 80 plus 200 times 60 over 500, and we get 72 meters per second. So this makes sense because this mass is heavier, so the number is going to be closer to 80 than it is to 60. So hopefully you understand a bit more about the center of mass now.